You know when you search for a specific photo on your phone or that one old email and it just pops up in less than a second? How does that even happen? Well, it's not really about raw power. It's all about smart organization. Today, we're going to pull back the curtain on one of the most important ideas that makes our digital world feel so instant, the index. To really get this, we're going to start with something super simple and low-tech. A physical book. Seriously. Let's just forget about computers for a minute and picture a thick, heavy textbook.
Okay, so you need to find every single time a specific word is mentioned in that book. Your first thought probably isn't, I'll just read all 500 pages from front to back. I mean, that would take forever. So what's the shortcut we all instinctively take?
Right. You flip straight to the back and look for the index. It's such a simple, elegant solution that's so common we barely even think about it.
And that's really all an index is. It isn't the actual content of the book. Nope. It's just a small, sorted list of keywords that points you to the exact page numbers where you can find them. It's a guide. And this simple idea of pointing, well, that's what we're about to scale up to a massive level.
All right, let's take that exact concept and jump from that 500-page book into the digital world, a world with millions or even billions of pieces of information.
See, in the digital world, all this information is stored in what's called a database. And the easiest way to think about a database is just as a massive, perfectly organized digital filing cabinet. It's built specifically to be searched.
So inside that filing cabinet, data is usually stored in tables, kind of like a spreadsheet. Each row is a single item, like one book's author, title, and the year it was published. Now, with just a few rows like this, finding what you're looking for is a piece of cake. But this is where the real problem starts.
What happens when this table doesn't have 5 rows, but 5 million? Or what about 5 billion? All of a sudden, finding one specific entry becomes like searching for a needle in a continent-sized haystack. And here's the crucial part. Without an index, without a guide, the computer has no choice but to do exactly what we avoided with the book. It has to do a full scan. It literally looks at every single row, one by one, from the very top to the very bottom. And as that table gets bigger, this process just gets slower and slower and slower. This quote just illustrates the problem perfectly. It's like needing to find one sentence, but to find it, you have to search every single book in an entire library, page by page. It's just completely impractical.
So how do we fix this? Well, we go right back to that same elegant idea from the book. We give the database a digital version of a library's old-school card catalog.
In the world of databases, an index is a separate, much smaller table that acts just like that card catalog. It doesn't hold all the detailed info, it just holds 2 things: a keyword you can search for and a pointer to the exact location of the full record. That's it.
And here's how it works in practice. Instead of scanning that huge main table, a search query goes to the small, organized index first. It finds the item there, and then, boom, it uses that pointer to jump directly to the correct row in the main table. It completely skips everything else. It's a massive shortcut.
The difference here is just night and day. On one side, you have that slow, plodding, row-by-row scan. On the other, a direct jump. And as the data grows, the without index method gets impossibly slow, while the with index method stays lightning fast. It doesn't matter if it's 1,000 rows or 1 billion. This is a total game changer for performance.
Okay, so this is a really cool technical concept, for sure. But why does it actually matter? Where do we see this playing out in our own lives? Well, it turns out this is the invisible engine behind pretty much everything you do online. How can a search engine comb through the entire internet in a fraction of a second? Indexes. How does your social media feed load instantly out of millions of posts? Indexes. Finding a product on a shopping site, searching your email, it's all built on this one incredibly powerful idea of organization.
And this really gets to the core lesson here. You know, making things faster isn't always about throwing more powerful hardware or more raw processing power at the problem. More often than not, the biggest performance gains come from just being better organized. A smart structure will outperform brute force almost every time. And it's a powerful reminder that sometimes the most advanced technology that makes our entire digital world possible is built on an idea as simple, as timeless, and as humble as the index in the back of a book.